Hello guys, welcome back to my YouTube channel. So in today's video, let's discuss about some special first order differential equations. In this video, we'll be discussing about Bernoulli's equation, Riccati's equation and Clairaut's equation. So before we get started, press the like button, comment if you have any suggestions to improve my way of teaching. Also share it with your friends so that it will keep me motivating to do more and more of these. And don't forget to press the subscribe button so that you'll be getting immediate notification as soon as I post the video. So let's get started. So what's actually a Bernoulli's equation? Some non-linear first order differential equations can be reduced to linear form through this equation. These may be some non-homogeneous equations which are not linear. So till now we didn't have any problem while facing a linear equation. But what if it's not linear? If it is of anything of higher order, which is of power n over here, this equation is very similar to the linear equation, but the only difference is that there's a power of n. So with this, we'll be learning how to solve a problem. Let's look at this question. Y dash plus 4xy plus xy cube is equal to 0. Here, the n is equal to 3 for the Bernoulli's equation, wherein this is the general form of the Bernoulli's equation. Now, if we have a look at it, y dash can be also written as minus x cube minus 4xy. So this is the first method to solve a Bernoulli's equation. Let v of x is equal to y power 1 minus 3. This must be written in the form of v of x equal to y power 1 minus n, where n is the value over here. So v of x in this case becomes y power minus 2. So dv by dx is differentiation of this becomes minus 2 y whole cube dy by dx. Now if we substitute the value of dv by dx, that's y dash, in the equation 1, this equation, then this becomes minus 2y cube into minus xy cube minus 4xy. From this, dv by dx is equal to 2 times x plus 4xy square. This y square is y power minus 2, which is equal to 2 times x plus 4v. Hence the equation becomes dv by dx minus 8xv is equal to 2v. Now this is again in the form of a linear equation, wherein here we have already seen. In my previous video, I have mentioned how to solve a linear equation. If you had missed it, please do watch the video and come back to this. So let's now proceed. The integration factor is nothing but e power of integral p of x. Here the p of x is nothing but minus 8x. So integral of minus 8x becomes e power minus 4x square. Then the equation after multiplying with the integration factor becomes v times of e power of minus 4x square is equal to integral e power minus 4x square into 2x dx. So after this integration, it becomes minus 1 by 4 e power of minus 4x square plus c, wherein c is the integration constant. So if I divide entire thing by e power minus 4 by x square, v is equal to minus 1 by 4 plus c into e power 4x square, or v is nothing but y power minus 2. So 1 by y square minus 1 by 4 plus c into e power 4x square. Now if I send this one and rearrange, the solution becomes y is equal to c into e power 4x square minus 1 by 4 whole power of minus 1 by 2. Alright, here we look at another such equation called Riccati's equation. Its general form is y dash is equal to p of x y square plus q of x into y plus r of x. This is a kind of special case of Bernoulli's equation, and that will be obtained when the r of x term is 0 with the n is equal to 2 for this one. In Bernoulli's equation, we had the power of y to the power of n. Here it's a square. It's a square. So we can observe that this reduces to Bernoulli's equation with n is equal to 2 and r of x equal to 0. So let's now solve this kind of equation with an example. Let y dash is equal to y square minus 2x minus 1 times y plus x square minus x plus 1. In this type of equation, we have to initially assume that y equal to x plus 1 by z. This x can be anything. This x can be something of v of x. It can be any function of x. Or you can take simply as 1 plus 1 by z. I am here considering it as x plus 1 by z while solving this problem. So if y is this, y dash becomes 1 minus z dash by z square. So now substituting the value of y dash in the above equation, we will be getting it as 1 minus z dash by z square is equal to x plus 1 by z whole square. This is from the value we obtained of y minus 2x minus 1 into x plus 1 by z plus x square minus x plus 1. So this is nothing but, after rearranging, x square plus 2x by z plus 1 by z square minus 2x square plus 2x by z minus x minus 1 by z plus x square minus x plus 1. Here it's nothing but z dash is equal to minus z square into 1 by z square plus 1 by z. We had obtained this by arranging the above equation, or this can also be written as z dash plus z is equal to 1. This we had taken by taking z square as the LCM, and z square and z square becomes cancelled. Here it becomes z plus 1 and one of the z goes to the other side. So you can understand how we got z dash plus z is equal to 1. Now we find that integration factor is equal to e power integral 1 into dx, which is equal to ex. If you are imagining how we got this, just check my previous video in which I have explained how to solve a linear differential equation. So this is there in that, and we got integration factor from that. Now multiplying this equation with the integration factor, it becomes z into e power x is equal to minus e power x plus c, wherein c is the integration constant, and z is equal to minus 1 plus c into e power minus x. This we had obtained by dividing entire thing with e power x. The solution can be written as y is equal to x plus z, wherein we had initially assumed, and now replacing that z with the terms of x and y, we can obtain this as y is equal to x plus 1 by c into e power minus x minus 1. Alright guys, we have another set of equation called Clairaut's equation. This is a non-linear differential equation of the form y is equal to x y dash plus f of y dash, wherein f of y dash is nothing but function of y dash. To solve these kind of problem, let's now look at it with an example. Here is an example of y is equal to x y dash plus y dash whole square. To solve this problem, we must assume first one thing, that let y dash is equal to p. After substituting this p in this equation, we will be obtaining that x is equal to 1 by p into y minus p square. Let this be equation 1. Now substituting this 1 in the above equation, we have got that. So let's now differentiate this and obtain another equation. After differentiating this with respect to y, this becomes dx by dy, which is nothing but just inverse of dy by dx. Since dy by dx or y dash is equal to p, dx by dy is nothing but 1 by p. So this equation becomes 1 by p is equal to 1 by p minus y by p square into dp by dy minus dp by dy. This we can obtain from the UV rule. Next, after this 1 by p and 1 by p are getting cancelled and we have taken dp by dy as common, y by p square plus 1 into dp by dy is equal to 0. Now that we are having two things, y by p square plus 1 or dp by dy is equal to 0. In this, while solving Clairaut's equation, we'll always have this kind of thing wherein dp by dy and some other equation will be equal to 0. So if you have to solve this, we must consider two cases wherein either dp by dy is equal to 0 or y by p square plus 1 is equal to 0. What happens if dp by dy is equal to 0? If dp by dy is equal to 0, p is equal to some integration constant c. The equation now becomes, by substituting p as c, then y dash becomes c, alright, then y is equal to c into x plus c the whole square. So this becomes the final equation when dp by dy is equal to 0. What if dp by dy is not equal to 0 and y by p square plus 1 is equal to 0? So let's now look that. If y by p square plus 1 is equal to 0, y is equal to minus p square. So if y is equal to minus p square, let's substitute in the equation. Minus p square is equal to p into x plus p square, or x is nothing but minus 2p. From the values of x and y, we can obtain an equation such that y is equal to minus p square, which is nothing but minus of x square by 4. Now send 4 to the other side and bring x to the one side. Then it becomes x square plus 4y is equal to 0, which represents a parabola. So this is how we solve all the three equations in these methods. Now, as I have again mentioned, please like the video, comment if you are having any suggestions to improve my method, and also share it so that it keeps me motivating to do more of these videos. And also don't forget to subscribe button. Thank you so much.